Like last today, we're gonna come to chapter 4, system of linear. We come to section 4.1, the types of linear system and their graphs. So keep in mind that we will have actually like 3 types of linear system, and we will learn about that later. So what is a system of linear equations? Definition is it is a set of equation where we're looking for the coordinate point or set of point that satisfy all the equations. So usually in 2-dimension, we have solution of system of a system is in form as x comma y. So we need to have x value and we need to have y value. Okay, so down here is example 4.1, which is an example of a system that's have 2 linear for part A, and it's going to have 2 unknowns, which is x and y. For part B, we will have a system with 3 linear equations with 3 unknown as x, y, and z. Yeah. All right. So let's we have an example, which is an application for the system of linear equations. So a small business produce soaps and lotion, gift baskets, labor, utilities, and other fixed expense cost is about 6,000 a month. So this is like a fixed cost. And what else? We have each basket costs about $8 to produce. And we decide to sell for $20. So this is the price in here is P will be equal to $20. All right. And because of if you have price, you can have revenues function as pi times demand, which is 20 times the x in here. All right. I'm gonna put down this as x equals to 20x. So this is a linear. This is linear equation. All right. So before we learned was in a special case when we have like a selling price is a fixed as like a number constant. We're going to have a revenues is a linear function, and we're going to call this question number 1. All right. Now let's set up a cost function. Okay, so we're going to have cost function. Use a blue one, right? So cost CMX will be the fixed cost plus the variable times x. And that we will have CMX will be equal to 6,000 plus with each item cost gonna be $8 and time with the number item gonna be x. So we can have in here is a linear equation number 2. So we are combine these 2 equations and make it as at function number 1 which is the revenues equal to 20x. And the cost equal to 6,000 per x. So if we want to find the solutions, I mean, if we want to find the break-even point, which is when we set up revenue equal to cost side, to cost function. So we can say set 20x equal to 6,000 plus 8x, right? Because we can substitute 20x equal to 6,000 plus 8x, and we can just, you know, subtract 8x both sides, right? X equal to 6,000. All right, and then we have 12x equal to 6,000. We can have x equal to 6,000 divided by 12. And that we're gonna have x equal to 500. So this mean what? Let me say here. This mean revenue at finance will be the cost at finance and will be equal to 10,000. And the solution is in the form as x and y, which is going to be in the form is going to be finance and 10,000. Yeah. Okay. So we will have this intersection here. Is coordinate at finance and 10,000. Okay. So definition. The solutions of a system equation is a point or set of point which satisfy all the equation. Okay, what does that mean, right? So let's have example exercise below here, 4.1. We want to confirm that the point 511 is a solution of the system, right? So how can we do that? We have to, you know, check if the solution here, if the point here satisfies for all the equation, right? Okay, so check with x equal to 5 and y equal to 11 into the system, right? So how to do that? Substitute both equation here with the value of x equal 5 and y equal to 11 and see if it choose statement or not. So for equation number 1, we have 2 times 5 minus 3 times 11, and the right hand side going to be negative 23. So is that true statement? Let's simplify. 10 minus 33 equal to 23 and negative 23. Is that true statement? Yes, it is true. All right. True. Right. So this is good. The first one is good. Now, what about the second one? 4 times x. X now is 5 minus y. Y now is 11. So and right side equal to 9. So let's simplify it. I have 20 minus 11 equal to 9. Oh, did it choose statement on top? So since both shoes, and I'm making it become red. All right. Since the point satisfy all the equation. Therefore, this point, phi 11 is a solution of the system. Okay. So from now on, you will, if we ask you about if the point is a solution of the system, then you have to do like, check with substitute the value into the into all the equation and solve it. Okay. Now let's talk about the type of linear system. So like I said before, we have 3 types, right? And as you see below here, right? The first one is a system that have one intersection, right? One intersection point, right? The second one have parallels, so no intersection. Right? And the last one is okay that you have only look like you have only one line. So actually the both line is overlap each other, right? Overlap each other. So it look like it just should become one line. So since it's become one line, how many intersections do we have? It's just always intersection, right? It's always intersection. Like all the point on here will be the intersection point, right? All the point on the line will be the intersection point, right? So that's we call infinite many solution in this case. Okay, so let's take a look at the name of each types. The first one, when we have only one intersection, is called independent system. We have exactly one solution. Right. Two line is cost always just only one. There's no way you have more than one. Okay. Second K is inconsistent system. Sorry, inconsistent system. We have no solution because it was parallel line. And the last K is is dependent system, which has infinitely many solutions. And these occur when the lines are on top of each other, and they are same line. So in three dimensions, so this I call like 2 dimension, and it is 3 dimension. We have the first one is like all these planes intersect. Right, you have the blue plane and the green plane and yellow plane intersect at one point. So the second type when we call inconsistent system, as you can see, it could be like two plane intersect, but the last one not intersect at the same point. So there's no intersection point for all three of them in this case. Right? It could be one of them cross two other parallels, and still you don't have any intersection point that there's all three plane go through. Lastly, the case there's three of them just parallels and absolutely you have no intersection point at all. Okay, so the dependent system for 3Ds is a case could be like, you know, all of them cross as one line, and this line still have like many many solution, because you have like all the point on the line will be the solution. So I would say all three plane line up in this case. We mostly actually focus on 2D, but sometime later we're gonna talk about 3Ds. Okay, so let's we come down and do an examples in 2D. Yeah. Okay, so we're gonna learn about three methods to solve. We have three methods to solve linear system. Okay. And let's come with example 4.3. Let's start with graphing method. And graphing methods, we just look by eye. Just look by eye. Just look by eyes to the graph, and guess the solution. Right. So graphing it will not give you an accurate answer, and we may have to, you know, confirm that. Right. Okay, so let's check with the first one. Right. So the first system here is 2x plus 3y equal to 25, negative 5x minus y equal to negative 56. So for the solution here, the point over here will be the solution. Right. So what is this coordinate of, what is the coordinate of this point? So as you can see now, we have the first one, part A. This system 2x plus 3y equal to 25 and negative 5x minus y equal to negative 56 is the intersection that has a two lines with an intersection point at we'll say 11 and 1. Right. So that means what? That means solution is 11, 1. I mean, I usually write as x, y equal to this. Okay. I would say, I guess the solution is. Okay, because since by eyes you can only guess that it could be like 11.1 and 1.1, right? And so we can't really sure about that, right? Okay, so what about the second one? As you can see here, maybe I would say maybe is this 10 point, I don't know, maybe 1.5 and maybe 0.23, maybe, right? Because who knows, for this one, it's really hard to see that, right? It was a very difficult to tell, right? So note that graphical method is a quick look at the graph and guess. So we may not have a perfect, accurate answer, right, or solution. Okay. Now, let's we move to another method, and we call this method is substitution methods. And this substitution methods is recommend that if the system has an equation which has been isolated. So what does that mean? Let's call this equation 1 and it is equation 2, right? And let's say step 1. Isolate a variables in one equation. Yeah. So for this step, for this part B, we actually have y have been isolated for equation 1 already. So I would say equation 1 has been isolated y variables in equation 1 has been isolated. So we're done, right? We've done this step. Then we're gonna move to step 2. That's step 2. Step 2, I gonna say using the expression of the results. Let's say the results in step 1 and substitute into the other equation. The other equation. Let me move this. Okay. So for this step, we can see that in the second equation, we have negative x plus 4y. And y now we have been isolated and solved and get is 2x plus 8 in step 1. 2x plus 8. All right. So I mean, I can say in here is y equal to 2x plus 8. Right. So I substitute 2x plus 8 in here in the second equation. And I got negative 6x plus 4 times 2x plus 8 equal 26. And then I'm gonna have negative 6x plus 8x plus 32 equal to 26. Simplifying, I have negative 2x plus with 32 equal 26. 32. And then I have negative 2x will be equal to 26 minus 32, which equal to, okay, so that's right. Which I have negative 2x equal to negative 6. Okay. And that's, I can have x equal to negative 6 divided by negative 2. And that means I have 3 as the answer here. Let me make sure. Let me make sure. So there is so right now I end up with x equal to 3. Right? Is that the answer? Right. We have the solution in form as x and y, right? We haven't have y value yet. Right? We need to have y value. Maybe I will have to save some paste. So I will move up this guy. And then this guy will be move up. Yeah. Does it look better? Right. I see that I make a small mistake here. The negative 2x should be 2x only because negative 6x plus 8x is 2x, right? So change this. This should be 2 only. So this should be x equal to negative 3. So now I'm gonna have the last step. Okay, so let's move this one here. Step 3. I have to move this up a little bit to save my display, I think. Okay, step 3. All right. So what is step 3? Step 3, I want to have, I'm going to use the result in step 2 and substitute into the step 1. All right. So step one, we have y equal to 2x plus 8. And highlight it to make sure. Right. So we have we're gonna have y equal to 2x now become -3 plus 8. So we have y will be equal to -6 plus 8, which means y will be equal to -2. No, actually 2, sorry. All right. So the solution need to have two things, right? One is the value of x and the other one is value of y. So I would say solution is x comma y will equal to -3 comma 2. All right. So I'm done this substitution methods. Okay. We'll change this to be I don't know, maybe this color. No, let's do this color. All right. So now I'm going to teach you another method, and it's named elimination methods. And how to solve it? Okay, I would recommend that if the system hasn't has not been isolated for any equation, right? Then you should use elimination. Okay. So let's say step one. And you see right now you have systems that haven't been isolated at all, right? So step one, choose a variables to eliminate and multiply, I say cross, multiply both equation with the coefficient with the opposites coefficient. Where's the opposite coefficient? Of this variable. So you can either choose variable x or choose variable y, doesn't matter. Okay, you can choose, I mean, you can choose, I'm gonna choose variable x, okay, for this case. Let's choose variable x. Let's choose variables x. to eliminate. So we will cross multiply for equation 1 with -3 or maybe 3, and equation 2 with 4. Okay, so now as you can see, I am having 4 and -3 here, right? So I will multiply by -3. No, actually 3 and 4. One of them must be, I mean, you cross multiply, right? So one of them must be negative, and one of them would be positive after multiply. Okay, so I will have to change my word a little bit to make this one better. Cross multiply with their question. And try to make a new coefficient with opposite side. That make better. So as you see now, if I multiply 3 with the whole equation number 1 and 4 with the whole equation number 2, what happened? Okay, let's see, right? So I will have 3 equation 1 will be equal to, will be 3 times 4 is 12x plus 3 times 3 is 9y, I mean, equal to 37 times 3 is, check using calculator, 3 times 37, 111, right? And for 4 times with equation number 2, I will have negative 12x. So 4 times negative 3x, right? And then plus with, make this, plus with 4 times 2 is 8y equal to negative 128. Okay. So what I need to do now is I add both. I'm gonna add to this, add them up, right? Step 2 is add them up. So I will have 0x and 17y. is the left hand side, and the right hand side will give me negative 17. And I call it is step 2. Say step 2. And both hand side. Both equation. Both hand side. Two equation. Right. And you will now get 17 y equal to negative 17. And we'll say and solve for y. Solve for unknown. So let's solve for the unknown. We have y will be equal to 17 divided by negative 17 divided by 7, right? Negative 17 divided by 17, we equal to negative 1. Okay, so I'm done with step 2. Now I'm going to move to step 3. And I say, what am I going to do? Substitute the result in step 2 into any equation, any original equation. Yeah. And solve for the unknown. So that means what? That means I'm gonna use that's y equal to negative 1 and substitute into any equation. Let's choose equation number 1, say for x plus 3y, y now change to be negative 1 equal to 37. So then I have 4x equal to, no, 4x minus 3 equal to 37. And then I have 4x equal to 40. I add 3 both sides, right? Then x will be equal to 40 divided by 4. That means x will be equal to 10. So that means what? Solution is x comma y will equal to 10 comma negative 1. That's going to be the solution. Yeah. So for this elimination, you don't have to always thinking about doing x or eliminate x first. You can also do eliminate y first. That's fine, right? You can just multiply, cross multiply the coefficient of y term there. You have like 3 and 2, right? So you can multiply 2 for the first one and 3 for the second one, and then try to make it also on opposite side. So one of them will be negative. So after that, adding them together. So that should be it. Okay. Now I'm gonna go ahead and move down. Okay, so this I will let you guys to practice with it. For the answer key of solution, it's going to be a over 5, no, over 3, comma negative 5 over 3 for the first one. The second one will be 2 comma 7, no, negative 7, I mean. And the last one will be 1440 comma 1000. So you can go ahead and pause my video and try it first, okay? And check if you have the answer key as mine. I would like to show you for problem number 2, maybe, but as you can see, the question says solve the following with using any methods you choose for each problem, and keep in mind that don't try graphical method, okay? Because that may not showing us it's going to be a perfect answer, right? Okay. I would like to show you guys on A here, because I think you will have to deal with some number that you guys may long time no see and maybe worry about it. So let me show you guys, right? So first, you want to think about which method you should use in here. I would recommend you use elimination, since it have, I mean, both of the equation haven't been isolated, so we're just gonna apply substitution methods, I mean elimination methods. Let's use elimination. Okay, and as you see in here, you can either isolate, I mean eliminate y or eliminate x, doesn't matter with us, right? As you see, it was number 2 here and it was number 1 here, right? You can cross it, right? And you will have now as 1 here and 2 here, right? Make one of them become negative, so let's choose -1 for the second one. So you will have 2 times equation 1 will be what? 4x minus 2y equal to 14. And then the second one will be -1 times e to the 2, right? Equation 2. So you want to have what? Let's we have, I made a mistake. I cross multiply should make this way. 2 here, 1 here, right? Sorry. So let's change this. So if it is 1 here and 2 here, there should be 2x minus y and 7. So it not change that. For the second one, it's going to be -2x and -2 times 2 will be plus 4y equal to -6. 6 times -2 will be -12. All right. So let me use this red one. So we can add them up, and we have 0x plus 3y equal to 7 minus 12 will be -5, right? So that means y will be equal to -5/3. Okay. So this give me y equals to -5/3. So how can we handle after that? So we have substitute y equal to -5/3 into either equation 1 or equation 2, whatever you like. So let's choose here equation 1. Here's equation 2. Which one you like? Let's do equation 1. Okay. Then you have what? Then you will have x minus 2x minus -5/3, right? Equal to 7. So simplify, I have 2x plus 5/3 equals 7. Okay, so maybe you guys will not will worry about this step, right? So subtract both sides by 5/3. 5/3. How to do this one? You can either convert the 7 there to be the same denominators with 5/3. So what does that mean? 2x equal to 21/3 minus 5/3, right? 7 is 21/3. Let's see, right now I have the same denominators. And because of that, I will have I will maybe have to move this up here and say 2x equal to 21 minus 5/3, right? Do operation in top, keep the bottom, and that we have 2x equal to 2x equal to 16/3. Okay. Someone say, oh, this is too hard for you. How can you handle that, right? Okay, let me teach you how to use calculators, okay? Okay, so let's start from here, right? I have 7 minus 5/3, right? So people say 7 minus 5/3. Right, put out on the calculators, enter. You have something not very nice in decimal. You need to change it to be fraction form. Click math. And number 1 is fraction things, enter. So that's gonna be 16/3, right? 16/3 here. Okay, so after that, we have 2x will be equal to 16/3. You have 2x. Oh, sorry. You're gonna have x will be equal to 16/3 divided by 2, right? Divided by 2. Or you can just do like put out 2 in here. Same meaning. All right. So that will give us as x equal to 8/3 as the answer for this. We have y here. We have x here. So you're gonna say, oh, this look not really easy for you sometime. Okay, let me show you. So we have 16/3 here, right? You want to divide by 2, right? So make 16/3. You divide by 2. See what I'm having here? I'm having 16/3 at the top, at the numerator. I divide by 2 here, right? I will have some number that not really nice. Make a math and fraction. You will have the answer as 8/3, right? So if you what did I do? If you okay with hand calculations for this, when you shown was shown with the fraction things, go ahead and try that. But I allow you to use calculator for this case. So you can either go with calculators or by hand. That's okay to me. All right. I don't want to show them B or C, since they both want to give us a nice number. But as you can see that for B, I would recommend use substitution method to handle this. Because you see that I have like the second equation almost isolate the y value already. You can just, divide by 10 both sides, you can isolate it, right? So you can go and use solution methods. For C, I would also using substitution methods by, as you see that one of the equation here was being isolated at FP. Both of them actually have been isolated already. You can just either substitute 1720 minus 0.5 p into the FP here, the second one, and you're gonna end up with a equation that's 1720 minus 0.5 p equal to 0.375 p plus with 460, and then you solve for p and then substitute into one equation to find the f of p. All right. So then answer would be this guy. Try that, okay? Now, I would like to move to example 4.4. A campus club hold a bake sale to raise money and sold brownies and chocolate chip cookie. They priced the brownies at $2 and cookie at $1. And they raised, maybe I'm gonna use other color for this. So they raise they raised $250 and sold 175 items. We want to know how many browns and how many cookie was sold. Right. So brown in green, cookies in yellows. So let's call B is numbers of brownies. I mean, I can call it X and Y, actually, you know, let's call X and Y, sure. And Y is numbers of cookie. All right, so if I call X is number of brown and Y is number of cookie, what do I have for revenues? Okay, and you see that the price for brown is $2, right? So I'm gonna have like 2 times with wait a second. 2 times with X, right? Plus with 1 times with Y. And that will give us $250, right? This because they say that the rate $250, right? And the second equation I can say I have like 175 items, so that means X is number of browns plus number of cookie will be 175 items. So now we have a system equation have been set up with 2 equations and 2 unknowns. And in this case, I would suggest using eliminations. Maybe you want to multiply by -2 for the second one and 1 for the first one. Then you want to have like 2x plus 1y equal to 50 and -2x minus 2y equal to 1. That will be 300. 702 350. Okay, so you will have 0x and negative y. This will be negative y. Minus negative 400. So you will have y equal to 100. Right? So you will substitute into maybe equation number 1 or maybe number 2, I think. Right? Into equation 2, we have x plus with 100 equal to 175, which means x will be equal to 75. So the number of brownies will be 75 and cookie will be 100. So that will be the application for linear system, right? Okay, so we may want to try exercise 4.3. Let's set up equation first, right? Let's read together. Movie club need to raise money and decide to sell empanadas and tamales. So the price empanadas is 4 and tamale is 3, and they raise $1,015 and sold so one item on 800 285 items. Change this one to be blue. Then we're gonna find the number of tamales and number of empanadas. So we may gonna just say X is numbers of empanadas. Y is number of tamales. So then we will have 4x plus 3y equal to $1,015 since they raised that, right? So after selling X number of empanadas and Y number of tamales, you will have $1,015. And the totals of item going to be X plus Y, which will be equal to 285. So we may gonna name this E1, this E2, something like that. Okay, so you can either think about canceling X or elimination X or Y, doesn't matter to us. I wanna just eliminate the X. So I will multiply with 1 for the first and -4 for the second. So I have 4x plus 3y equal to 1,015. Second one will be -4x minus 4y equal to use a calculator. It's gonna do 4 times with 285, 1,140. This give me -y. Equal to, something happened with my pen. Let me use the other one. Should this be negative, right? And 1,015 minus for 140 will be -125. Okay. So we have do I miss something? Negative. So that y will be equal to 125. And I will just say substitute y equal to 125. into equation 2, either one of them, right? So we're gonna have y x plus with 125 equal to 285, and then we have x equal to 285 minus 125, so then x equal to 160. So the answer for number of empanadas is 160, and for tamales will be 125. Okay. So I will have to move to the next one. And for this one, we have 2 apples and 4 bananas. Right. And total cost will be $2. Say 3 apples and 5 bananas will cost $2.75. So we want to find the price of each. Find the price of each time. So it could be like could be apple or banana. We have to find both. So let's say price of 1 apple is, let's say x is price of 1 apple. And y is price of 1 banana. So as you can see that if I have 2 apples and 4 bananas, which mean I have 2x plus 4y, which equal to $2. And the other one gonna be 3 bananas plus 5 apple, and that's gonna be 2.70. So try to solve this, and you will have answer key for apple cost will be 40 cents for 1 apple and 30 cents for 1 banana. Got? Okay, I want to teach you guys one more important things of supplies and the price equations. So we did learn about demand equations before. Price demand in terms of price or price in terms of demand before, and mostly in order to set up the price, we actually depend on the demand, right? But now I also want to show you another case that we have price in terms of supply or supply in terms of price, because sometimes we also think about the side in the side of the supplier. We can also determine the price to make it consistent. And when we match up of these two case, such as like the demand and the supply equal each other, we will have a point called equilibrium point. Or I would say this is going to be okay. Okay, so that's okay. Just gonna using equilibrium point in the form as price and F of P, which is demand and supply at the same time. This okay, so we have company that make 52 inches LED TV are willing to produce more TV if they can sell them at higher price. So pretty more if they have higher price. So the supply TV is also a function of the price at which these TV will sell. So suppose that the supply equation is LP equal to 0.25p plus 580. As you see now, this function was have the slope is positive, right? Which mean the higher price, the higher demand you want to have. I mean, the higher supply you want to have, right? So higher price, higher supply. All right. So in the other side, we also have a price demand equations, or I say demand price, demand internal price. All right. Let me say. No, actually, it's just called price demand equation is. Okay, so we have demand equations is F of P equal to 1,600 minus 0.6 P, with having a negative slope. My higher price, less demand. Or lower demand. So we can set up the system equation as FP equal to 0.25p plus 580s, and the other one going to be FP equal to 1/600 minus 0.60p. And you can solve for this one by just substitution methods if you want. You can just set up, 0.25 p plus 5/80 equal to the other side 1/600 minus 0.6 p, right? And then solve for p for this equation. Okay, you will have p. You will have to add 0.6 p both sides. So we have 0.85 p plus 580. And then you minus 580 both sides. Okay, so we'll minus 580 both sides. Then I have 0.85 equal to 1,200. Let me see to make sure. $1,020 p. So then I have p will be equal to 1,020 divided by 0.85. We are gonna have p equal to 880. And at this is the price that you're really happy with it. With the demand will accept it, and the supply will also will also okay with that. And make F a P. Oh, I made a mistake here. The price will be 1,200, and demand will be demand and supply at this point. They both want to be equal to. You can substitute in any one of the equation, original one, and I use the demand equations. 0.60 time with, you know what? Let me just use more space. It's gonna be 1/600 minus 0.6 times 1/200, and that means F of P will be equal to 880 and demand and supply. So we done section 4.1 here, and we're gonna talk about Gaussian elimination later in section 4.2. We'll see you later.